Hello dear students, this is your engineering mathematics 3 lecture. Today's topic is inverse Laplace transform. This topic is from second unit. In previous lecture we discussed Laplace transform. Now inverse Laplace transform. What is the definition of inverse Laplace transform? L raised to minus 1 means this is the operator used for or notation used for inverse Laplace transform. So called as inverse Laplace transform of f of s is equal to f of t. For function f of t, we find the Laplace transform. It is always f of s. And when we find the inverse Laplace transform, the reverse process, we find the inverse Laplace transform of the function f of s, and it is equal to f of t. Reverse of Laplace transform, inverse Laplace transform. Inverse Laplace of some functions here. Inverse Laplace transform of 1 upon s minus a is equal to e raised to at. Inverse Laplace transform of 1 upon s raised to n plus 1 is equal to t raised to n upon n factorial, or it is also equal to t raised to n upon gamma n plus 1. It is equal to t raised to n upon n factorial when n is positive integer. Inverse Laplace transform of 1 upon s square plus s square is 1 upon a into sine at. Inverse Laplace transform of 1 upon s square minus a square is 1 upon a into hyperbolic sine function sine at. Inverse Laplace transform of s upon s square plus a square is equal to cos function cos at. Inverse Laplace transform of s upon s square minus a square is hyperbolic cos function cos at hyperbolic cos. Inverse Laplace transform of 1 by s is equal to 1. Inverse Laplace transform of s upon s square plus a square whole square is t upon 2a to sine at. Inverse Laplace transform of integration over s to infinity f of s ds is equal to f of t upon t. Inverse Laplace transform of f of s upon s is equal to integration over 0 to t f of t dt. Inverse Laplace transform of e raised to minus as into f of s is equal to f of t minus a into u of t minus a. So these are the results. These are the inverse Laplace transform of some functions. Now example, find the inverse Laplace transform of 3s minus 8 upon s square plus 4. Now to separate here both the terms, because in numerator there are two terms, subtraction of two terms, so you separate both the terms here in solution. Inverse Laplace transform of 3s minus 8 upon s square plus 4 is equal to 3 constant, so we can write it inside the bracket 3 into inverse Laplace transform of s upon s square plus 4 minus 8 to inverse Laplace transform of 1 upon s square plus 4. It is equal to 3 into inverse Laplace transform of s upon s square plus 4. It is nothing but cos 2t using the formula of inverse Laplace transform of, we are using this formula here, inverse Laplace transform of s upon s square plus a square is cos 80. Okay, and so the inverse Laplace transform of s upon s square plus 4 is cos 2t minus 8 as it is. Inverse Laplace transform of 1 upon s square plus 4 is nothing but sine 2t upon 2. 8 upon 2, 4. That's why the coefficient is here 4. Because 1 upon s square plus 4, its inverse Laplace transform is sine 2t upon 2. And this 8 is there, so 8 upon 2, 4. That's why the term is 4 here. So this is the inverse Laplace transform for 3s minus 8 upon s square plus 4. Okay. Now the next example. Find the inverse Laplace transform of 2s plus 5 upon s square plus 4s plus 13. Now here, inverse Laplace transform of this function is nothing but your function f of t. Okay. Now we can write this 2s plus 5 as 2 into bracket s plus 2 plus 1. If we solve the bracket term, it is 2s plus 4, but actual original term is 2s plus 5. So add a 1, so that you will get, after solving the bracket term, you will get the complete term 2s plus 5 upon s square plus 4s plus 13. So in denominator, you adjust the term s square plus 4s plus 4, s square plus 4s plus 4 plus 9. You can split 13 as 4 plus 9. And then s square plus 4s plus 4 is the perfect square. This is s plus 2 whole square plus 9. And so, inverse Laplace transform of this 2 into bracket s plus 2 bracket complete plus 1 upon s plus 2 whole square plus 9 is here. The every term of s is displaced by s plus 2. So using shifting property, we can reduce this term as e raised to minus 2t, because the term s is displaced by s plus 2. So the power of exponential function is minus 2t, e to the power minus 2t into inverse Laplace of f of s. Now what is inverse Laplace of f of s? E raised to minus 2t into inverse Laplace of. Now remove this plus 2 term, because its work is over here. We have replaced it by e raised to minus 2t. So in place of s plus 2, now the term will be only s, because we have replaced that s plus 2 by exponential function using shifting property here, e raised to minus 2t into inverse Laplace of 2s plus 1 upon s square plus 9. Now in numerator there is addition of 2 terms, so you separate both the terms. So e raised to minus 2t as it is. Inverse Laplace transform of 2 constant s upon s square plus 9 plus 1 upon s square plus 9. So f of t is equal to e raised to minus 2t as it is. 2 is constant term, so it is as 2 as it is. S upon s square plus 9. Inverse Laplace of s upon s square plus 9 is cos 3t. And inverse Laplace transform of 1 upon s square plus 9 is sin 3t upon 3. So this is your answer for the second example. Now the third example is here. Find the inverse Laplace transform of vs plus 1 upon s plus 1 whole cube. It is equal to function of t, inverse Laplace transform of the function vs plus 1 upon s plus 1 to the power 4 is f of t. Now the denominator term is displaced in the form of s plus 1. So we can rearrange the numerator term also in the form of s plus 1. We can write the term 3s plus 1 as 3 into bracket s plus 1. If we solve this bracket term, it is 3s plus 3. The constant term is plus 3, but in original term it is plus 1. So if we subtract 2, then the term will be 3s plus 1. See, 3s plus 3 minus 2 is 3s plus 1 upon s plus 1 to the power 4. Okay, here s is displaced by s plus 1 here. So again, using shifting property here, f of t is equal to, now s is displaced by s plus 1. So you write here the coefficient of exponential function minus 1. So it is e to the power minus t, inverse Laplace of 3s minus 2 upon s raised to 4. So the term is e raised to minus t into inverse Laplace transform of 3s minus 2 upon s raised to 4. So e raised to minus t as it is. Now in numerator there are 2 terms, we separate these 2 terms. So inverse Laplace of 3s upon s raised to 4 means 3 upon s raised to 3 minus 2 upon s raised to 4. So it is equal to e raised to minus t. So inverse Laplace of 3 upon s raised to 3 is 3 constant as it is. 1 upon s cube, it is 3 square upon 2 factorial. We are using this formula here. We are using this second formula. Inverse Laplace of 1 upon s raised to n plus 1 is 3 raised to n upon n factorial. We are using this formula there. here. So 3 constant, 1 upon s cube, its inverse Laplace is t square upon 2 factorial minus 2 constant, inverse Laplace transform of 1 upon s raised to 4 is t cube upon 3 factorial using the same formula. And so f of t is equal to e raised to minus t upon 2 t square minus 2 upon 3 factorial. 3 factorial means 6. 3 into 2 into 1. 6. 2 upon 6 means 1 by 3. 1 by 3 into t cube. So this is your answer for the given one. Next is find the inverse Laplace transform of 1 upon s square plus a square whole square. Now you assume that inverse Laplace, you know that inverse Laplace transform of 1 upon s square plus a square is 1 upon a into sin a t. This is the formula. Now if we differentiate this term 1 upon s square plus a square with respect to s, property of derivative in Laplace transform, inverse Laplace transform of derivative term, derivative of f of s term, it is equal to nothing but minus t into f of t. This is the property of Laplace transform, property of derivative in Laplace transform. Okay. So inverse Laplace transform of what is your f of s? F of s is here 1 upon s square plus a square. So write it in place of f of s 1 upon s square plus a square derivative. It is equal to minus t into f of t. Minus t into f of t is here 1 upon a into sin a t. Okay. So here differentiate this 1 upon s square plus a square with respect to s. So its derivative is nothing but 1 upon s square plus a square whole square minus sin minus 1 upon s square plus a square whole square, and the composite derivative of s square is 2s. So the complete derivative is minus 2s upon s square plus a square whole square is equal to minus t upon a sin a t. So this is the term here. And then we are interested in the inverse Laplace transform of 1 upon s square plus a square whole square. So use here the integral property, because we have to remove this s which is present in numerator, because in our original example the term is only 1 upon s square plus a square whole square. So how to remove this s? Then use here the division by s property. Inverse Laplace transform of 1 upon s into f of s is equal to integration over 0 to t f of t dt. This property is here in the result. You can see inverse Laplace transform of f of s upon s is nothing but is equal to integration over 0 to t f of t dt. This property is there. So it is inverse Laplace transform of 1 upon s into f of s is equal to integration over 0 to t f of t dt. And so now what is f of s? F of s is this term minus 2s upon s square plus a square whole square. This on both sides negative sign is there, so the negative sign get cancelled. The term is only 2s upon s square plus a square whole square. Okay, and divided by s. It is equal to nothing but integration of 0 to t f of t. F of t is here t upon a into sin a t dt. Okay, now this s get cancelled. And so it is inverse Laplace transform of 1 upon s square plus a square whole square is equal to, you shift this 2 here in RHS, it is in numerator. So when we transfer it in RHS, it will be in denominator. So it is 1 upon 2. Again, inside the integral, the term is 1 upon a, which is constant. So outside the integral, we can write the constant term 1 upon 2a into integration over 0 to t sin a t dt. Okay. And so this is your answer here. Now, but how to solve this integration? Integration over 0 to t sin a t dt. 1 upon 2a as it is, t sin a t, use there u into v rule to integrate it for the limit 0 to t. Now what is u and what is v? Derivative of t vanishes earlier as compared to sine function. So assume t as u. So u as it is means t as it is. Then v1 means integration of sine function sin a t. So integration is minus cos 80 upon a, because variable is t, a is coefficient. So integration is minus cos 80 upon a, minus second term minus sign into derivative of u. U is here t, derivative of t with respect to t is 1, another bracket v2. V2 means integration of v1. V1 is here minus cos 80 upon a. Its integration is minus sign as it is. Integration of cos function is sin 80 upon a. Already one a is there, so a into a is square. So the term is minus sin 80 upon a square. The next term will be 0 because derivative of 1 is 0. So no need to write the next term. And limits are 0 to t. Now upper limit is t. So that it is equal to 1 upon 2a. 1 upon 2a as it is. Upper limit is t. So put t is equal to t. If we put t is equal to t, it is minus t into cos 80 upon a minus minus plus sin 80 upon a square. Lower limit is 0. So t is equal to 0. Sin 0 is 0. So it is minus t cos 80 upon a plus sin 80 upon a square. And so if we simplify it, the term is here 1 upon 2a is constant term. So you write 1 upon 2a as it is. And 1 upon a square is also constant. So take common in both terms. So that we can write here 1 upon 2a cube inside the bracket sin 80 minus 80 cos 80. And the last example is here, find the inverse Laplace transform of 1 upon s into s square plus 4. Now how to find the inverse Laplace transform of 1 upon s into s square plus 4? It is equal to 1 inverse Laplace transform of 1 upon s square plus 4 is equal to sin 2t upon 2. Now 1 by s division by s property. Division by s property means you just integrate the function over 0 to t. Integrate the function over 0 to t. Function is there 1 by 2 into sin 2t. And then you solve this integration 1 by 2 into sin 2t. 1 by 2 constant, so as it is. Integration of sin 2t is minus cos 2t upon 2, limit 0 to t. And 1 by 2 as it is. Upper limit is t, so minus cos 2t upon 2 minus minus plus lower limit 0. And for lower limit we take minus sign. Already minus sign is there, so minus minus plus. Lower limit is 0, put t is equal to 0. If t is equal to 0, cos 0 is 1. So the term is 1 by 2. Now 1 by 2 is common in both the terms, so take it common. So it is equal to 1 by 4 into 1 minus cos 2t. So this is your answer here. So these are the examples based on inverse Laplace transform. This topic is inverse Laplace transform is over here. Thank you.